Here's how most people first try running AI coding agents in parallel. Open 2 terminals, start 2 sessions in the same directory, hope, and it breaks in ways that are completely predictable because Git allows exactly 1 active branch per checkout. Agent is mid-task on the auth refactor. You switch branches to let agent B fix a timeout bug, and agent is now editing files that changed under its feet. Stashing kills momentum. 2 agents touching the same file produce the kind of merge conflict that takes longer than the original task. The tooling wasn't wrong. The workspace model was. Meanwhile, the creator of Claude Code has described running around 5 terminal sessions across separate checkouts, plus another 5 to 10 through the browser and mobile, 10 to 15 parallel workstreams, 1 person. The difference between that and the 2-terminal disaster is not talent, and it's not a secret model. It's an isolation discipline built on a Git feature older than most AI companies, the worktree. This is the hands-on companion to the harness anatomy video, Agent Engineering, Part 2. By the end, you'll run parallel agents safely, know when not to, and recognize which of the 5 parallelization tools fits which job. Terminals out. Chapter 2, what a worktree actually is, because the concept takes 90 seconds and removes all the mystery. 1 Git repository can support multiple working directories at the same time. That's the whole feature. Each worktree is a separate folder on disk, checked out to its OWN branch with its own files, its own uncommitted changes, its own everything a session touches. But they all share the same underlying repository, the same object database, the same history, the same remotes. Commit in 1 worktree, and the commit exists for all of them instantly, because there is only 1 repository underneath. Now map that onto agents and the 2-terminal disaster dissolves. Each agent gets its own directory and its own branch. No branch switching under anyone's feet because nobody shares a checkout. No stashing because nobody needs to clear the stage for anyone else. No same file collisions during work because the files are physically separate copies. The agents only meet at merge time, on your terms, in an order you choose. An old, boring, rock-solid Git feature turns out to be exactly the isolation layer parallel agents were waiting for. Chapter 3, the native support, because since early this year you don't even wire this up yourself. Claude Code ships built-in worktree management. Pass the worktree flag with a name, and it creates the worktree, creates the branch, and starts the session inside it, 1 command. By default, the worktree lands in a dedicated folder under your repository root, on a branch named after the worktree. Skip the name and it generates one for you, usually something charming like Bright Running Fox. Run the same command with a different name in a second terminal, and you have 2 isolated sessions on 1 repo. That's the entire setup. 2 practical notes before the demo. First, workspace trust applies. If you've never run the tool in that repository before, the worktree flag will ask you to run it there once normally and accept trust, security respecting a boundary, exactly as it should. Second, and this matters for everything in this video, this feature is a moving target. It shipped early this year and has received meaningful changes every few weeks since: confirmation prompts, permission behavior, isolation fixes. The workflow I'm teaching is current as of filming and the principles are stable, but check the changelog before assuming details. You know this channel's law by now, check the date, then trust. Housekeeping while we're here, because worktrees you can't list are worktrees you'll forget. See everything at once with the worktree list command, plain git. It shows every directory, its branch, and its state, your parallel estate on one screen. When a task ships, remove its worktree with the remove command, and the directory disappears while the branch and its commits remain safely in the repository. Abandoned experiments prune away just as easily. Make the list command a habit, start of day, end of day, and orphaned workspaces never accumulate. The estate stays as clean as the workflow. Chapter 4, hands-on 2 sessions, 0 conflicts. Terminal 1, start a session with the worktree flag named for the feature, say the auth work. Watch what happens. A fresh directory appears under the worktrees folder, a new branch is created, and the session opens with its working directory inside that isolated copy. Terminal 2, same command, different name, the payment bug. 2 agents, 2 directories, 2 branches, 1 repository. Give them their tasks and let them run. Nothing either one does can touch the other's files, and neither can touch your main checkout, where you're still free to read code, review diffs, or just watch. Pause and name what this is because you've seen it before. This is Organ 5 from the anatomy video, State and Isolation, wearing a terminal interface. Each agent's workspace is its own durable, inspectable state. The branches are the typed artifacts, the merge is the verification gate. The harness theory wasn't abstract, it's running in your two terminals right now. When the anatomy video said long horizon safety is a harness guarantee, not a model capability, this is what that looks like in practice. The model didn't get smarter between the broken version and this one. The workspace model did. And notice the role your main checkout just acquired. It's the observation deck. While the agents work in their isolated copies, your original directory stays untouched. You can read code calmly, run the worktree list to see the estate, and diff any agent's branch against main. All without entering a workspace or interrupting a run. Watching diffs accumulate from the outside, while the workers stay undisturbed inside, is the quiet superpower of this whole arrangement, and it's the posture you'll live in, conductor's podium, not player's chair. Chapter 5, Making Worktrees Usable the Moment They're Created, the step everyone skips and then pays for. A fresh worktree contains your tracked files and nothing else. Your environment file, not tracked, not there. Installed dependencies, not tracked, not there. So the agent starts, tries to run the tests, and fails on a missing environment before it writes a line of code. The polish is a small include file in your repository that tells the tool which untracked files to carry into new worktrees, your environment templates, local configuration, the things a session needs on arrival. Dependencies deserve one honest sentence each. Every worktree is its own directory, so language ecosystems that install dependencies into the project folder need an install step per worktree, budget for it, script it, or line on ecosystem caches that make the second install nearly instant. The professional pattern, a tiny setup script in the repo, install, copy environment, verify tests pass, and the first instruction to any new agent is run the setup script. 30 seconds of ritual, and every agent starts from a known good state instead of a mystery. Usable on arrival is a discipline, not a default. Chapter 6, the decision framework, because more agents is not automatically more speed, and this is where the practitioners separate from the enthusiasts. The one rule that governs everything, only parallelize tasks that are fully independent with no shared file state. Independent means different parts of the code base, no ordering between them, and no shared contract that's still being decided. A user interface polish task, a build tooling task, and a documentation task, beautifully parallel. Two tasks that both touch the payment module. That's not parallelism, that's a merge conflict with a countdown timer. The sequence that makes it work, and notice it's the harness video's planning organ all over again. Plan first in the main worktree before any parallel session exists. Decide the shared contracts, the interfaces, the types, the API shapes, so workers build against agreements, not guesses. Split by ownership boundaries, each worker owns files no other worker touches. Then and only then, fan out. Real teams running this daily describe exactly that shape, 4 or 5 agents, each in its own file domain, 0 overlap by construction. The parallelism was designed before it was launched. That's why it worked. One more calibration, task size. The parallel sweet spot is tasks an agent finishes in roughly half an hour to a couple of hours. Smaller than that, and the worktree ceremony, create, setup, review, merge, costs more than the work. Larger and long-running branches drift from main, merge pain grows with every passing hour, and the goal drift failure mode from the anatomy video gets its opening. Big feature. Slice it into contract-sized pieces that land independently, and let landing often be the drift control. Parallel agents reward the same decomposition instincts that always distinguished senior engineers. That's not a coincidence. Chapter 7, the menu, because worktrees are one of 5 parallelization tools the official docs now describe, and choosing the wrong one is this month's most common self-inflicted wound. Worktrees, full sessions, full file isolation, for independent tasks you supervise in separate terminals. Subagents, delegated workers inside one session, sharing your checkout for research and exploration that doesn't collide on files. Subagent isolation, the hybrid your one session spawns workers, and each gets its OWN worktree automatically, parallel file edits without you managing terminals. Agent teams, coordinated sessions with a shared task list, heavier machinery for genuinely coordinated work, and the batch command, repo-wide mechanical changes, renames, migrations applied at scale. 5 tools. The selector is simple. Do the workers need to edit files independently? Worktree-based options. Do they only need to read, search, and report? Plain subagents. Is it one mechanical change everywhere? Batch. Match the tool to the collision profile, and most of the pain never happens. Chapter 8, the hands-free version, Subagent isolation, because managing 4 terminals is a hobby, not a requirement. Inside one session, you ask for parallel implementation work, and with isolation configured for subagents, the harness spawns each worker into its own automatically created worktree. They edit in parallel in the background without stepping on each other and without you juggling windows. As each finishes, you review its diff, merge its branch, and remove its worktree. One conductor, several instruments, and the isolation machinery is invisible until you go looking for it. This is the closest thing yet to delegating to a small team from a single prompt. The coordination pattern the community has converged on is worth stealing even if you build nothing else from this video, the orchestrator convention. The main worktree acts as coordinator. Each worker writes a small status file as it progresses, a few fields, state, summary, files changed, and drops a results summary in its workspace when done. The orchestrator, or you, polls those files instead of interrogating sessions. It's the Blackboard pattern from the anatomy video, implemented with JSON files and a directory listing. No framework, no message bus, no magic. Files, the most battle-tested coordination technology in computing. Chapter 9, the merge discipline where parallel work becomes shipped work or becomes archaeology. 3 habits. First, review each worktree's diff before merging in the worktree where its tests can run against its own state. Second, merge in dependency order. If the API worker's output feeds the UI worker's assumptions, the API branch lands first, and the UI branch rebases onto reality. Third, the one everyone skips. After all branches land, run one final validation pass on the merged result, full tests, full build, because 4 branches that each passed alone can still disagree in combination. Per worker green is necessary, merged green is the actual bar. The harness video called this the verification organ. Here it's just 3 habits and the discipline to keep them when you're tired. Chapter 10, real numbers, so your expectations are calibrated by practitioners instead of thumbnails. The tool's creator recommends 3 to 5 terminal worktree sessions as the sweet spot and reaches 10 to 15 total workstreams only by adding browser and mobile sessions for lighter tasks. Teams running this daily report 4 to 8 concurrent worktrees per developer as the reliable ceiling. And listen to why the ceiling exists, because it's the most honest sentence in this whole topic. Above that, you're bottlenecked on review, not on the agents. Every parallel branch is a diff a human must understand and approve. Your attention is the scarce resource. The agents just made that obvious. Do the arithmetic once and the discipline installs itself. If reviewing a solid branch takes you 20 to 30 minutes, then 8 agents finishing hourly produce more review than your day contains. So scale parallelism to your review budget, not your ambition. Start with 2 or 3 worktrees for real feature work, keep 1 lane for quick fixes, and expand only when your merge queue is consistently empty. The goal was never a screenshot full of terminals. It's shipped, reviewed, trustworthy code per unit of your attention. Parallelism is a multiplier on throughput only when review keeps up. After that, it's a multiplier on backlog. Chapter 11, the traps, 5 of them collected from the field so you can walk around them. The trust error, the worktree flag exits asking for workspace trust, run once normally in the repo, except proceed. The empty environment failure, agent starts, tests fail on a missing environment file, that's the include file discipline from chapter 5. The continuous integration surprise, locally your worktrees share one object database, but a CI runner does a fresh checkout, so never let a workflow depend on that sharing. The overlap failure, 2 agents editing the same file was never bad luck, it's a decomposition error, and the fix is ownership boundaries, not better merging. and the cost lesson from a documented large-scale run that burned through tens of billions of tokens. Parallel agents multiply spending exactly as fast as they multiply work, so the budget ceilings from the harness video apply per worktree, and tighter decomposition is usually the cheapest optimization available. Chapter 12, Two Lenses. First, your team runs 4 parallel agents, and every merge day produces painful conflicts in the same shared module, the fix. Options, a smarter merge tool, instruct agents to pull from main more often, redraw the task boundaries so exactly one agent owns that module, and others consume its interface, or reduce to 2 agents. The merge tool treats the symptom. Frequent pulls shrink the conflict but keep the collision. Having the agents halves the throughput and keeps the disease. Redrawing ownership eliminates the conflict by construction. Same file collisions are decomposition failures always. Boundaries first, tooling second. Second lens, an engineer scales from 3 worktrees to 10 and reports that total shipped work went down, the most likely cause. Options, the model degrades with more sessions. The laptop can't handle 10 directories. Review became the bottleneck and unreviewed branches piled up into stale, conflicting backlog, or worktrees corrupt the repository at scale. The model doesn't know how many siblings it has. Disk space is not the issue, and worktrees are rock-solid Git. The answer is the ceiling chapter. 10 agents produce review demand no calendar contains, branches age breeds conflicts, and throughput inverts. Scale to your review budget. The bottleneck is and was always going to be you. Chapter 13, the whole workflow distilled to 7 steps you can run tomorrow morning. 1. Plan in the main worktree contracts and interfaces first. 2. Split by ownership, no shared files between workers. 3. Fan out 1 worktree flag per task, or subagent isolation if you'd rather conduct than juggle. 4. Set up script first thing in every new worktree. 5. Workers write status files, you poll the blackboard. 6. Review each diff in its worktree, merge in dependency order. 7. 1 final validation pass on the merged whole. That's it, no framework to install, no platform to buy. A 20-year-old Git feature, 1 flag, and the harness discipline from part 1 of this series. And that's Agent Engineering Part 2. The anatomy video gave you the organs. This one gave you a workflow where you can watch state isolation, planning, and verification do their jobs in real terminals. Next on the channel, we're going somewhere new, the agentic web, what happens when your site's most important visitor isn't a person anymore, and how builders should prepare for agents as first-class users. Subscribe so it finds you. If this video saves you even one branch switch disaster, you know where the like button is. We're building AI up from the ground, one blueprint at a time. See you in the next one.